Have you ever looked at a chemical equation and thought, how am I supposed to balance this? The numbers feel random, the formulas look intimidating, and suddenly, chemistry feels impossible. But what if I told you that balancing chemical equations is actually just organized counting? Today, I will teach you the simplest and easiest way to balance any chemical equation, step by step, with the real examples. We will start easy, then average, then a difficult one. By the end of this video, you will feel confident solving them on your own. Let us begin. Before we solve anything, let us understand one important rule. Chemistry follows the law of conservation of mass. That means atoms are never created. Atoms are never destroyed. They are only rearranged. So balancing an equation simply means making sure the number of atoms on the left side equals the number of atoms on the right side. Remember, you are not changing the formula. You are only adding numbers in front of the formulas. These numbers are called coefficients. Never change the small numbers inside the formula. Those are called subscripts. Now, let us apply the simplest method. Step 1. Write the equation clearly. Step 2. Count atoms on both sides. Step 3. Start balancing one element at a time. Step number 4. Leave hydrogen and oxygen for last if possible. Step number 5. Recount everything at the end. That is it. Now let us try examples. Example number 1. Hydrogen reacts with oxygen to form water. Here is the unbalanced equation. Now let us count the atoms. We will start from the left side. On the left side, hydrogen is 2 and oxygen is 2. On the right side, hydrogen is 2, oxygen is 1. As you can see, oxygen is not balanced. Step 2. Let us balance oxygen first. As you can see, there are 2 oxygen atoms on the left, but only 1 on the right. So put number 2 in front of H2O. Now, count again. As you can see, on the right side, our hydrogen is 4 and oxygen is 2. Now, hydrogen is not balanced. As you can see, on the left side, hydrogen is only 2. Right side, hydrogen is only 4. So put number 2 in front of H2. Now, count again. On the left side, hydrogen is 4, oxygen is 2. On the right side, the hydrogen is 4, oxygen is 2. Therefore, the chemical equation is balanced. That was easy, right? Just counting and adjusting. Example number 2. Methane reacts with oxygen to form carbon dioxide and water. Here is the unbalanced equation. Now let us count the atoms. On the left side, carbon is 1, hydrogen is 4, oxygen is 2. On the right side, carbon is 1, hydrogen is 2, oxygen is 3. Step number 2, balance carbon first. As you can see, carbon is already balanced. Now let us proceed to hydrogen. As you can see, there are 4 hydrogens on the left and only 2 on the right. So put number 2 in front of H2O. Now count again. As you can see, on the right side, Hydrogen is 4. Oxygen is 4. Next, we will balance the oxygen. As you can see on the left side has 2 oxygen atoms. On the right side has 4 oxygen atoms. So now let us put 2 in front of O2. Now count everything again. On the left side, carbon is 1, hydrogen is 4, oxygen is 4. On the right side, carbon is 1, hydrogen is 4, oxygen is 4. Therefore, it is balanced. Notice the pattern. Carbon first, hydrogen next, oxygen last. Next example is iron reacts with oxygen to form iron oxide. Here is the unbalanced equation. Okay, let us count atoms. On the left side, iron is 1, oxygen is 2. On the right side, iron is 2, oxygen is 3. As you can see, both elements are unbalanced. This looks harder because 2 and 3 do not match easily. When you see 2 and 3, think about their least common multiple. The least common multiple of 2 and 3 is 6. So let us make oxygen equal to 6 on both sides. Let us adjust the oxygen, okay? To get 6 oxygen atoms, as you can see on the right side, F2O3 has 3 oxygen atoms. If we put number 2 in front of it, now oxygen on the right side would be 3 times 2 is equal to 6. To get 6 oxygen atoms on the left, put number 3 in front of O2. Now, oxygen is balanced at 6. Next, balance the iron. As you can see on the right side, 2Fe2O3 means 2 times 2 is equal to 4 iron atoms. So put number 4 in front of iron. Now count everything. On the left side, iron is 4, oxygen is 6. On the right side, iron is 4, oxygen is 6. Now it is balanced. When numbers do not match easily, think of the least common multiple. That trick makes difficult equations manageable. Now, let us proceed to our last example. As you can see, this chemical reaction has parentheses, polyatomic ions, multiple elements, and even starting numbers. That is why it looks scary, but we will follow a simple structure. Now, let us count all atoms. On the left side, aluminum is 2, sulfur is 3, calcium is 1, hydrogen is 2, and oxygen is 14. On the right side, aluminum is 1, sulfur is 1, calcium is 1, hydrogen is 3, oxygen is 7. As you can see, everything is unbalanced except calcium. Now, let's start with the most complicated compound. Class usually start with a compound that contains the most different elements. And for this chemical reaction, we will start with Al2SO4. Okay? It has 2 aluminum and 3 sulfate groups. As you can see, there are 3 sulfates on the left, but only 1 on the right. So put number 3 in front of calcium sulfate. Now, as you can see, sulfur is balanced. Now we will recount the calcium. Right side now has 3 calcium, so put number 3 in front of CaOH. Therefore, calcium is balanced. Next, let us balance the aluminum. As you can see, the left side has 2 aluminum, okay? And on the right side has 1. So you have to put number 2 in front of AlOH. Now, aluminum is balanced. Step number 4, check oxygen and hydrogen. We will carefully recount everything, okay? On the left side, aluminum is 2, sulfur is 3, calcium is 3, hydrogen is 6, oxygen is 18. On the right side, aluminum is 2, sulfur is 3, calcium is 3, hydrogen is 6, and oxygen is 18. Everything matches. But notice something important. We did not guess randomly. We counted carefully. We balanced polyatomic ions as a group and adjusted coefficients step by step and recounted at the end. That is the secret. This is my tip for you. When you see a polyatomic ions like SO4 or OH that appear on both sides, treat them as a unit first. That makes difficult equations much easier. Important reminders: never change subscripts. This is wrong, okay? Changing H2O into H3O. The correct way is put a number in front like 2H2O and always recount at the end. If everything matches, you are done. If chemistry ever made you feel overwhelmed, remember this. Balancing chemical equations is not about memorizing. It is about patient counting. It is logic. It is pattern recognition. It is step-by-step thinking. And you are capable of that. If this video helped you understand balancing equations in the simplest way, comment balance below, so I know you made it to the end. And if you want more easy chemistry tutorials explained clearly and calmly, subscribe and turn on notifications. Chemistry is not hard. It just needs to be explained the right way. See you in the next lesson.